The technique for solving equations is very simple. It is firstly, find the number furthest from the letter. Secondly, shift it to the other side of the equal sign. Thirdly, reverse its mathematical process. We repeat these 3 steps until the letter is by itself. Then we have our solution. So which equations can be solved? Only those containing one letter or symbol used as a pronumeral for the missing value. Remember this: if we have one unknown in an equation, we can find its value. If we have 2 or more, we cannot, unless we are given more information. Here are some examples. If the original equation is 2x plus y equals 25, we cannot use it to find the value of x. But if we are given extra information, such as y is 5, we can modify that first equation, 2x plus 5 equals 25, and we can find x. So in this case, x is 10. If the original equation is 2x plus y is 25, as we said, we cannot find x. But if the extra information, such as x is twice as big as y, we can use it. Twice 2y plus 5 equals 25. That equation only has one unknown, whatever is represented by the letter y, and we can find its value. We know 5y is 25, so y equals 5, and we have a unique solution. But that value is not x. Remember, we were told x is twice as big as y. That means x is 10. And we have another unique solution. So in conclusion, one equation can lead to only one value. For 2 missing quantities, we need 2 equations. So we can make one equation that's better. For the word equation, we can substitute a piece of information or a numerical fact. So if we examine our formal solving process, let's assume we're asked to find the values of x and y when the following 2 equations are supplied. 2x plus y is 16 and y is x plus 7. Here is an efficient way of processing the information. Our first fact, 2x plus y is 16, will not lead to a solution. So we use the additional information to modify our original equation. We can tidy that up and put it in a form which leads to a standard solution. So x is 3. And knowing that x is 3 allows us to find the value of the second unknown, so we know that y is 10. In the first column, our focus is on the first unknown. We begin with the general information. We substitute the details about the specific case, and solving leads to a numerical conclusion. Notice the general information and the specific details were supplied. So the process is generally, now in this case, so in conclusion. The third column does the same, but it focuses on the second unknown. So we have, what do we know generally? Do we know anything specific for this case? And because we do, we can draw a conclusion. Think about this carefully. Make sure you understand how this difficult mathematics is simply the basic three-step thought pattern used more than once. And our basic three-step pattern is examine what's happening generally. What are you investigating? Specifically in this case, what do you know about it? And what conclusion can you draw as a result of using a little logic? Now notice the way the solution's been set out. All progress directed towards finding the value of one of the unknowns is set out vertically. This keeps a clear focus on achieving the goal. Effort directed towards overcoming a complication moves horizontally. This keeps our two different thought processes clearly in mind and prevents the relevant logic from interfering with our basic solution progress. There's an obvious strategic versus tactical mindset here. So our first concern, how big is X? We have our problem and we focus and work towards a solution. But along the way, we had to use supporting information and we treated that horizontally. Now at the end, always check that you've answered everything the question asked for. In this case, there's a second answer required. But that's a very simple calculation. 3 steps as usual. But it's kept vertically in its own column. Look closely at the solution. Can you see that it's being divided up into 3 zones? That reduces the complexity of the task. It is now 3 simple activities which are easy to manage because they have a natural sequence. There's a preliminary stage of getting things organised. There's the basic calculation, which only involves standard processing. And we have a supplementary stage because something else is required. So here's the original solution showing the 3 stages. Preliminary, solving the equation to find a value, and supplementary, is there anything else we need to find? So what we have looked at there today is very sophisticated mathematics. A difficult problem, But we have found that if we use strategic and tactical processing, it's quite easy. And if we assess it in terms of its zone, preliminary, the basic calculation, and anything supplementary, we have no difficulty in getting our solutions. We'll build on that next lesson. See you then.